Hello everyone, welcome to this video. In the previous video you have watched chemical equilibrium. So this video is also related to the previous chapter, and here we are going to learn all about the Le-Chatelier's principle. So Le-Chatelier's principle is really simple. Okay, just look at this example of the reversible reaction. A and B reactants converted to product C. So this principle says that when this reaction is at dynamic equilibrium, if there were any changes to the condition surrounding this reaction, we call it as external changes. Okay, so if there were any external changes taking place here, then something will happen within this reaction to try to counteract this external change. I repeat, if there was an external change made to the condition of this reaction, then within this reaction, something will take place to try to counteract the change. And this internal change here is always opposing, it's always found to be opposing this external change. Okay, I will be using a few examples below to try to illustrate to you the principle. Okay, so look at this reaction. We have got dinitrogen tetroxide that will be converted to 2 moles of nitrogen dioxide, and the molar enthalpy of this reaction is 58 kilojoule per mole, and it is an endothermic reaction because you can actually observe the positive sign here. So the very first change, remember this is external change that we're talking about. So assuming we human went and add more dinitrogen tetroxide into this particular reaction, which is already at dynamic equilibrium. Okay, I repeat, more dinitrogen tetroxide was added to this reaction when it has already reached the dynamic equilibrium. Try to think, what do you think would happen to the direction of the reaction? Will the reaction proceed to your right, or do you think it will go backwards? Which one would it be? I hope you got the answer right. That is, the direction will actually go towards the forward direction. Yeah, the forward reaction. Why? Because you already had a balanced amount of the reactant and the products. But now you have just added more dinitrogen tetroxide. So the system itself will try to bring it down. It will try to reduce the added dinitrogen tetroxide by increasing the amount of nitrogen dioxide. So the net direction of the movement would be to the forward reaction. In this second example, we are still using the same reaction, but this time around the external change is different. Here, the external change is when the surrounding temperature is increased. What do you think will happen to the net direction of the reaction? Now I'm giving you a hint here. You might want to refer to the molar enthalpy of this reaction here. So how was it? Now, let me use a very simple example. Your forward reaction in this case absorbs heat from the surrounding, whereas The back reaction will be the other way, that is, they release heat. Well, in this case, the surrounding temperature has gone up. So naturally, the internal system here, or the internal system here, will try to counteract it by decreasing it. Yeah, they will try to bring down the surrounding temperature. So the only way they can do this is by absorbing the excessive heat that has been supplied. Therefore, the reaction will go towards nitrogen dioxide. Okay, the net direction would be towards the forward reaction, because only through this way the excessive heat that is provided could be absorbed. Now in this third example, we will be looking at the pressure of the system. Similar reaction again, but in this case the external change is when the pressure of the system has gone down. So sometimes we will relate pressure of the system with volume. Imagine this. In the picture you could actually see that you have two boxes here, but although they have similar number of molecules, but this has a large, bigger space for the molecules. Therefore, we could also say that this condition would have a lower pressure if you were to compare to the first condition. So when the external change is about a drop in the pressure of the system, naturally the internal system will try to move the reaction so that a higher number of moles of molecules will be produced. Now here the number of moles is actually 1 versus 2. You look at the values, 2 and 1 here. So naturally the forward reaction would produce molecules of a higher pressure because they are more concentrated. Therefore, when the pressure of the system is decreased, what will happen is the forward reaction will be favored because it produces a higher number of moles of molecules. I hope now you will have a better understanding of how you should predict the direction of the reaction in order to counteract the external changes that took place.